Okay, so now that we have the network done, let's turn our attention to estimating the activity times. So let's go to the PowerPoint file. So here is that network that we just built. Okay, now how long will it take for each of these activities to complete? So as I mentioned earlier, CPM assigns just one time estimate for each activity, and that's because the when CPM was initially developed, that project had activities that were well understood and the times were deterministic. Whereas the people who developed PERT were involved in completely new activities, new technologies, and they didn't have any clear or deterministic idea of how long it will take, so they had to make estimates. So PERT employs a probability distribution, and specifically it's called PERT, it's called beta distribution, and there is a reason why beta distribution is appropriate. So an activity, say, can take anywhere between 1 and 5 weeks to complete. Okay. Now on the optimistic side, so you're very optimistic, then maybe it can take even less than a week. Okay. But if you're very pessimistic, then you may think, well, it may even take longer than 5 weeks. If you look at the possible times, there is a definite floor on the optimistic side, because however optimistic you may be, okay, the activity will have a definite floor below which even the most optimistic things that happen, and you still need certain amount of time, say 2 weeks or 3 weeks or whatever it may be. It's simply impossible to have an activity with, even if everything going perfectly, and you still have to spend a certain amount of time. So there is definitely a very solid floor. Whereas on the other side, if everything goes wrong, okay, so instead of taking 2 weeks, or instead of taking 3 weeks, 5 weeks, 10 weeks, 15 weeks, or the ceiling on the other hand is not a very solid ceiling like the floor is. There is a solid floor, but the ceiling is kind of not very solid. It could take a lot longer than even your most pessimistic estimates. So we come up with 3 possible time estimates: optimistic, pessimistic, and then what is most likely. And you will see that the distribution will be something like this. On the right side, on the ceiling side, the distribution is extended further out because of the fact that the ceiling is not as solid a ceiling like the floor is. Okay. And the general thumb rule, this is only a thumb rule, is the most optimistic time that you come up with has a probability of occurring of 1 in 100. So there's a 1% chance that you will be able to finish the activity by this time, A. And same here, there is a 1 in 100 chance, 1% chance that it will take as long as that amount. And then the most likely time, which is closer to the most optimistic time than that, once again because of the fact that the floor is a solid floor. Okay, so each activity is evaluated for 3 different times: optimistic, and we represent that with the letter A; pessimistic time with the letter B; okay, and then the most likely time with the letter M. Okay. So PERT often assumes time estimates follow beta distribution, which is this. Okay. And if the time estimate follows beta distribution, then from these 3 estimates we can compute a single estimate, what is called the expected time. So what is the expected time for each activity? So this is the formula that represents the beta distribution. If the distribution is beta, then this will give us the expected time, A plus 4m plus b over 6. And the variance of that time is given by this formula, b minus a over 6 squared, or b minus a squared over 36, okay, whichever way you want to write it. Okay. So here we are assuming that for each activity we have 3 times, and from these 3 times we can compute the expected time and the variance for each activity. So let's set this up in Excel.